So my talk's a little bit different. I'm going to be talking about brain-computer interfaces, and it's more of a future tech than something that is common today. So I'm going to explain what these are, what they're capable of, the ethics around them, and where we stand today. So how do these work? Firstly, we measure electrical activity in the brain using invasive or non-invasive devices. The non-invasive devices, you'll have an electrode on your scalp. Invasive devices, you'll have an electrode placed directly on the brain. So EEG is non-invasive, COGs are invasive. So we read these signals, we process them, and we turn these into commands. And I'm also going to mention EMG here, which pertains to reading electrical activity in one's muscles. Now, it's not directly related to BCIs, but it's important when considering hybrid technology. And we've all seen BCIs. We might not have interacted with them on a daily basis, but if we look at Iron Man and Elysium, they use, this is an example of exosuits that grant people superhuman abilities. In X-Men, we have Cerebro, which literally means brain. And this is used to enhance the brainwaves of telepaths. And in Avatar, we have our protagonists shifting their consciousness into another created organic being. And this is more brain-to-brain interfaces, but it's part of neurotech. And then you have the more chilling side of media depictions of this technology. And so Black Mirror is a fantastic example. This takes futures where brain or neurotech is common and is the norm around, and shows you some horrific stories related to those. And I'm not going to give away any spoilers, but the technology seen on the left has to do with immersive video games. On the bottom right, we can see tech that affects one's vision. And at the top right, we see it's a device that records one's memories. And while the media displays these devices as being a tech that can be used for unlimited possibility of good or evil, I'm going to reel this back to the real world, where we are now. And after this, I'm going to go into what could be. So I'm going to speak about motor neuroprosthetics, which is any brain-computer interface that results in physical movement. I'm going to go through some computer interface examples, and then go into video games and then art. So on the left, we can see Kathy Hutchinson controlling a freestanding robotic arm using just her thoughts. And on the right, we have Nathan Copeland, who has a device connected to his motor cortex and somatosensory cortex, meaning he can both control the movement of the arm and actually feel through the robot's digits. Then we have exosuits. So the military is actually investing millions in America on creating these devices, and it's a very difficult control system. And therefore needed to introduce this tech to control these suits better. And essentially these are used to improve the strength of soldiers, and the media has dubbed this the creation of super soldiers, but it essentially allows soldiers to carry heavier equipment over longer periods of time. And on the left, we have the Walk Again project, which essentially allows people to walk again who previously could not. And here we have an example of vehicle control. Now, this user is controlling the movement of that wheelchair using simply their thoughts. Moving to computer interfaces. The users here are able to operate a tablet, operating simple apps, moving a cursor, selecting, watching YouTube videos, or sending a mail. And then I found another very interesting use case, and that is using this technology as a lie detector. And in Iowa, in America, this is actually approved, and you can use this technology in a court of law as part of your defense. And the way it works is you can, there's a method called brain fingerprinting. So if you recognize a familiar image, your brain releases a P300 brainwave, and if it is not familiar, then there is no brainwave released or P300 wave released, and therefore you can tell if someone's lying or not. This tech can also be used for alertness monitoring. And next, video games, which is really exciting, at least for me. So we have somebody playing World of Warcraft on the left, using just their thoughts. It's basic commands, moving left, right, forward, back, and selecting. And on the right, we have a company called Control Labs, which was then bought by Facebook. It's a neurotech startup, and they're moving a object in a 3D virtual space. This time using signals, electrical signals in one's muscles and not one's brain, but we are likely to see hybrid technology in the future within this field. And neurotech, I mean, Neuralink, which a lot of people have heard about, actually trained a monkey to play Pong using just its thoughts. And we can play Tetris, Pac-Man, Pinball, Pong with this tech already. Now, another field I found interesting is using this to help people be artistic in a virtual space. You can paint or draw, and then there's also the clothing industry. So the accessory you see here comprises of motors and lights, and is controlled by 1,204 electrodes placed on the user's head. And this is called the Pangolin Scales Project, named because of the look of the electrodes on one's head. And so now I'm going to talk about the future of BCIs. And really, this is why I'm talking about BCIs in this space, is because while it will affect our lives outside of our work, it will also very much affect the future of tech and our careers, because I believe technology is linked. And I chose to focus on speech and communication here as my first point, and this is where the tech gets a bit chilling. We can control the movement of rats and cockroaches already, and make them jump off a ledge, or they can navigate a maze based on instructions we give them. But then you also have examples of brain-to-brain interfaces, or rather brain-to-computer interfaces, and then computer-to-brain interfaces. And here you have two rats placed in a separate box. The one rat receives a visual stimulus, say a red light, and the other rat will hit the red lever. What this means is you have two animals sharing the same sensory experience. Now, if you take that and put it in a human context, imagine sharing taste. If I taste something and I try to communicate exactly what that tastes like, if I taste the best strawberry in the box and I want you to know what it tastes like, I can try to communicate it in words, but I'm limited by the words. Then we have a picture which speaks 1,000 words, and you can imagine what it means to share a taste, that brain data with somebody. And then we also have advancements in neural typing. Facebook released a proof of concept in 2017, saying that they develop a device that would output 100 words per minute by 2020. This proved to be overly ambitious. And they dropped the project in 2021 when they bought out Control Labs and began working on other projects there. But it is still something that is continually being developed. And there are likely to be further advances in the tech I've already shown you. So vehicle control, both virtually and physically, immersive video game experiences, exosuits, prosthetics, that tech is all likely to improve over time. And it's important to talk about the ethical considerations when it comes to this technology. So in the media, we have depictions of mind control and dystopian futures where humans are slaves to technology. And really, this can serve as a warning. And while these are creative exaggerations, it is important to talk about the vulnerabilities around this tech and potential tech abuse. So we can think about data theft. It will be a major issue. But if we think about the most recent technological revolution, where we're able to share data with millions instantly, this came with issues. And with the rise of the internet and the openness it brought, we started seeing threats such as hackers and malware and scams, and data leaks, leaks of your private data. So you can imagine what this means in terms of brain data, data they're getting directly from your mind and subconscious. And then it's important to consider things like data ownership and consent. If I'm using an application connected to this tech, who owns the data? Do I need to share my data with that tech company or whoever created that app? Which brings me to regulations. Who can create and sell this technology? What is the limit of this tech? And these are all very important questions to consider. If we think about social media currently, it is a platform designed to be addictive. If you give someone the data response in your brain when exposed to a stimulus they provide, they can potentially make this more addictive or start neuromarketing. And then transparency is important. If you have the military field, the medical field, the corporate field, all working on this tech, especially in the corporate world, it's profit driven. So to know what's going on might be difficult. Speaking about the corporate world, it brings me to social implications. These companies are profit driven, meaning you need to buy the technology. If you're rich, you might have better access to the technology. And if we're talking about tech that can provide any sort of cognitive advantage or any advantage really that would make you more valuable to employers, you're more likely to be employed, which is going to increase social division and unequal distribution of wealth, which is an issue we already see, but could be worsened. And then transhumanist dependency. So today, if you think about laptops and cell phones, you already rely on them to remain competitive in the workspace and socially. If we reach a world where the norm might be to use brain-computer interfaces, if we don't have if we don't have keyboards or we don't need a mouse, you may be forced to adopt the technology despite being unwilling, just to keep up, just to remain employed. And really, I wanted to say thank you for listening, and I hope I've sparked some sort of interest. And I also wanted to say that there are hobbyists. If you do want to pick up this as a side hobby, there are open source projects that you can adopt. Yeah, and please feel free to reach out and chat to me. There's so much more I could say, but it was limited to some extent. And these are some of my references. Thank you, and please feel free to ask any questions.